Okay, yeah, we were talking about superheat, subcooling, the reasons we want the superheat again, just a review from 2 days ago. And yeah, so we want that superheat, we want a certain amount of superheat, and it does kind of change if you have a TXV, which I know you're not a fan of TXVs, but they're gonna be on everything here soon with all the efficiencies. And then they'll be a little higher if you've got a fixed orifice. So AJ, if you walk up to a system and inside where your evaporator coil is, the condensing unit coming in, you'll see like a little bulb coming out, then you know there's a TXV on the system. And so your superheat is going to be maintained a little better, between 8 and 12, they say. If it's above that, you might have some problems. Either it's faulty TXV or it's picking up too much heat. A lot of times if it's picking up too much heat, we're looking at airflow issues, and that is kind of what we're getting in today. Airflow affects our superheat going back out. If you have, not your filter's dirty, and you're slowing that airflow across that coil, well, it's not picking up as much heat. So what is that gonna do to your superheat?
Cool it.
It's gonna drop it down. You're gonna not have as much. So that coil's gonna get colder. Coil gets colder, it'll freeze up. That's why we get the freeze ups when the filter's dirty. Or let's say the ductwork was installed incorrectly. We don't put enough return air back to it. There's some checks that we can test with that kind of a thing with static pressure and stuff. And those are some other things that we're gonna get into, but that would definitely cause an airflow issue that would, crank that superheat, drive that superheat down and causing freeze ups in our coil. So that's why proper duct sizing is very crucial.
So is there a formula or something that you use? Like, how do you know when to use reducers?
Absolutely, yeah. So it's actually that amount of airflow. Each one of these ducts can carry a certain amount of airflow. That's why Jesh and I were underneath the house for so long. We were checking because we needed to get around some plumbing and making sure that our airflow is going to stay up. We were checking math equations and stuff to see, each ton that a furnace pumps out, the furnace airflow is done off a tonnage. Each ton that it does is about 400 CFM. So if it's a 2-ton unit, it's going to pump out 800 CFM. And then so on and so forth. If it's a 3-ton, and they go off a tonnage like that. If it's a 3-ton furnace, and that's just how much airflow it can do.
Which one do we have now?
A 5-ton.
We have a 5-ton.
So we need 2,000.
2,000, that's why our ductwork is so big, because we're splitting it, we're doing some zones. We're carrying 2,000 CFM of airflow out to where we need it to be. And then each one of our runs is gonna rob a certain amount of CFM going to different rooms. And don't quote me, because I don't exactly know. I mean, I'd have to look at a chart, because I don't know it off the top of my head. Refrigeration tech for so many years, so HVAC is still.
I was gonna say, do you have a chart? Or
I do have a chart. I gotta go track it down, find it. And that's one thing I wanna like print one up and like stick it up here. Because this is what.
All the time.
How do you measure the static pressure? Is it just from the math?
Actually, that's a really good thing. The static pressure is done with a manometer, what we check gas pressures with.
Okay.
You go in, not before the filter, you just take the filter out, and you can go right, basically, and then you want to point that has like a little arm in there, and you point it towards where the airflow is coming in. So you see how the airflow, I got kind of direction, it's going that way. You want it pointed that way so that it catches that pressure.
And you could only test it when the air's going?
Yeah, it has to be running. And then you test the airflow between the A coil and in the front of the furnace. Because you don't want to check the static pressure up here. What we're checking is just what's going on with the furnace.
If we assemble all this and find out that there's not enough pressure, too much pressure coming in, do we have to change
We have to
the
make
ducts?
another
We got-
engine?
That's why we do math and we check everything, because we don't want to change it once it's already up in the attic and the insulation's blown in. So that's why I'm like,
Once you have enough of them, then it doesn't matter.
Okay.
Yeah.
so
I mean,
once you do that and your static pressure,
for that one.
Yeah.
so you take that reading, that pressure here and that pressure here. Usually on your low side, it's going to be in a like negative pressure and a positive pressure up here. Don't pay attention to that negative. Just drop it off. Take that and take the other one and you add them together. You're looking, and this is rule of thumb, kind of rough, but about 0.5 inches of water column going across the furnace. Now you can also check your static pressure across your coil, across your filter, and that's just basically what you're doing is you're just looking away. You're just looking at what each thing is doing and how much drop is across it. Then you, I mean, it's easy just to pull out a filter and check to make sure it's good. But what you don't know is the filters that they're using might be too high of a setting or too high of a MERV rating. It's trying to pull too much out. Happens all the time. They're set up for 8 MERV. They go to Costco and they buy a 14. Slows that airflow down. Usually not crazy amounts, but let's say like with what happened at a gal's house with a slightly bad capacitor. Her fan wasn't running up to speed. She had a 14 MERV filter where it was designed for an 8, and it was just slowing it down, and the coil kept freezing up.
Oh.
And you know, everything seemed like it was working fine, but then if we ran that test, we would have found something's going on. We're not getting enough airflow across this thing.
I guess, yeah, a regular homeowner wouldn't know what kind of filter to get. They'll just get whatever fits.
They get whatever fits.
Yeah.
Exactly. Nobody tells them. Nobody's like, all right, so the math is this system was set up for an 8 MERV, you know, whatever. And really that's our job as techs to know what their system really needs and how it's set up. We do that with static pressure. That's how you check it. So you're checking it with a manometer here and here. Take the filter out. Each one of these vents is going to pump out a certain amount of CFM for the room. That's why in certain rooms we run a 7, an 8, because we're trying to get that amount of air to the size of room.
Mm-hmm.
And there's formulas for all of that stuff. Of course, do I know it off the top of my head? I should, but I don't.
Geez, that sounds like a lot of math.
And then each furnace,
What's that?
It
And
can be.
Yeah, they go
each
from-
furnace and air conditioner is sized for that house.
So they're all different.
Oh yeah, well I mean, that furnace is sitting right there. That's a a 5-ton thing furnace. It's a 120,000 BTU furnace. It's for a certain amount of square footage, certain size rooms, a certain amount of airflow we need, and then a smaller house. Let's say like my house that is 1,000 square foot. You 2-ton unit for cooling capacity, and I know a lot of the rule of thumbs, and there's a whole like math, there's books and books on it, and really only one that you need to worry about. I think it's like called the manual J, manual, I don't know, M. They have a whole bunch, and they do all that airflow and stuff. You need to get one of those and open it up and throw that up, kind of a situation. But knowing that your airflow can affect your superheat is something that we need to check, because like if you're getting too much or not enough going out there, what's causing that? Is it a charge issue? Is it an airflow issue? Well, then you do your checks with the superheat subcool, your pressures. Then you can go in and you can check your static pressure, and it can tell you, oh, must be an airflow issue. Let's start checking filters. Let's start checking, see if your airframe your coil is dirty, or your secondary heat exchanger is dirty. Something is slowing that airflow down. If everything's clean, everything's working good, then we need to start looking at ductwork. What's going on? Did they shove a bookcase in front of all the return airs and now it can't breathe?
We had that before.
It happens. It happens. Definitely. People don't know. They just set their furniture up, and the HVAC is an afterthought. And so, as techs, that's what we go in and do. When we're installing it, we install it correctly, because when we go back to preventative maintenance and repairs, it makes our life so much easier. And just a bad install is a bad install. You can't go back a lot of times, and you can do some stuff to kind of maintain it, to kind of get it up and going, but it's a problem, and I've seen it, and it's not good. So that is what we're going over today. Airflow, that's why you have to have return air. Return air is huge. You got to get enough back to the system. That's why I always check I actually check my return air first. Make sure that everything's, what is it breathing? What's it taking into its system? What's going on with the filter? How's the fan motor running? What's the secondary heat exchanger look like? Is there a problem with the A-frame coil? Did they do something weird? What we really ought to do is put a little spacer between this, and a lot of the better ones nowadays are doing that. They put like the little metal spacer right here between the furnace and the A-frame coil, just only so you can do that check with your manometer.
Just because it's kind of sketchy screwing in right next to the coil and
Yeah,
right next to your heat burners.
Yeah.
Because if you hit one of them, you're like, well, there goes all my refrigerant, or
Or
now I have a cracked heat
they
exchanger.
screw inside, because a lot of times you go right into the side of the furnace, and it's scary. That's
Yeah.
why you probably want to use like a step bit to do it, so you're not punching and put a hole through your heat exchanger, because then you're changing the furnace.
It always sketches.
But don't do that, because that's on my dime, and I would not be happy not changing out a furnace, because
You're putting those spacers in
yeah,
when you do installs?
Yep.
Cool.
they make them now.
Yeah.
Or just like a little stand.
Then I usually get one for the.
Sometimes, I mean, Josh could build one in probably 20 minutes,
Maybe.
if that. I mean, it's nothing big. It's just like a little. That much, maybe a couple inches, just to give you enough room to get your little probe inside there, or air tester. So, airflow is a big deal, and there is a formula to check how big your duct sizes is, how many runs you can take off of each one, and then how much to reduce it down to, so that each time it steps down, you're keeping that airflow up, because you're just robbing airflow to send the pressure, keep the pressure up. You know, like putting your finger over a hose keeps that pressure up. So, any questions on that?
Not really.
Not until we get out on the job
But I
site and
mean,
start seeing it.
like-
Well, it's just like, okay, think of this, and then when we're out there, you'll see it in real life, you'll see it in practice. And so, that's what it's all about. Right? That's why we do the trainings, is like, okay, you see it on the whiteboard, what does that mean? It means nothing, until you get out there and you start actually doing it. And then you start seeing, oh, this is why we're doing this. And then wrapping the ductwork, come summertime, it's losing that heat, and then all of a sudden your air blowing out of your vents is no longer at 55 degrees, it's at 7 degrees. That doesn't do anybody any good, it doesn't cool anything. And on top of that, it can condensate and cause all kinds of issues. So that's part of the wrapping, even though it's a pain and it's not fun, that's why we do it. So.
At this point,
On
we're